Okay, welcome everybody. Welcome to the NASA Earth Data webinar, Know Your Landsat, Accessing and Understanding Landsat Data. This is your host, Jennifer Brennan. I've got 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. So while everybody is logged in, we do have 2 polls at the bottom left and middle of the page we'd like you to answer if you could take a moment. I know that many of you have already answered the polling question. This is your host, Jennifer Brennan, but I'm also the NASA Earth Observing System Data and Information System, or EOS-DIS, User Support and Communications Lead at NASA Goddard Space Flight Center. What I'd like to do first is begin by going over a few housekeeping items related to this webinar. So first, due to the large number of participants and to ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or any questions, please enter them into the Q&A pod, and that's located in the lower right-hand corner of your screen here. That works like a chat, okay? This webinar will be recorded and posted not only to our online Earth Data Adobe Connect catalog as well as to our NASA Earth Data YouTube channel. The URL will be provided to you on the contact slide at the end. Additionally, all of the presentation files will be available for download at the end of the webinar. The webinar itself is 1 hour long, with 45 minutes being allocated to the presentation and live demonstration, and then another 15 minutes to the question and answer period. After the speakers have finished their presentations, what we'll do is we'll then move to a final set of polling questions, and then our question and answer period will follow directly after the final polling questions. So as I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar by using the Q&A pod, which is located in the right-hand corner of your screen. However, due to the large number of participants, we're not going to answer questions using the raising hand function. It has been disabled. What we'll do is we'll take all questions using the Q&A pod at the end. And just a final note, we do have a large group logging on today. So depending upon the volume of questions that are received at the end, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who might wish to stay on the line. So let's move next to the agenda. Okay, I'll pull that up for you here. Okay, the first 10 minutes or so will provide you with an overview for the Landsat project, introduce the basic technology behind Landsat missions, and provide several applications or use case examples for Landsat data. During the next 20 minutes or so, what we'll do is we'll switch speakers and move to a more detailed look at Landsat data products and a demonstration on how to access these data. Finally, we will finish with our third speaker highlighting a variety of Landsat educator resources. It is my pleasure to introduce our first speaker today, Laura Rocchio, who is a technical communications specialist for the NASA Landsat Project Office at Goddard Space Flight Center. Laura?
Good afternoon. This is Laura. I've had the opportunity to work for the Landsat project at NASA's Goddard Space Flight Center for the past 14 years, the last 5 of those remotely from Los Angeles. During this time, I've worked on projects ranging from forest cover research to science writing. I'm glad you've joined us today to get to know Landsat better. Landsat provides the longest continuous record of Earth land service from space. Landsat is a joint NASA-US Geological Survey program. NASA's role is to manage the design, build, and launch of the satellites, while USGS manages the ground system, post-launch satellite operations, and the data archive. But very importantly, both agencies work together to ensure that the satellites produce high-quality scientific data throughout their missions. Since 1972, Landsat satellites have been monitoring Earth, and all of the 3 million plus images they've collected are freely available for you to use from USGS. Landsat 8, the newest addition to the Landsat satellite family, launched from Vandenberg Air Force Base in California last year. A satellite launch is tremendously exciting, but also nerve-wracking because the success of years and years of work to build these precise scientific instruments comes down to successful launch, getting those instruments where they need to be in orbit. In a pre-launch interview with Wired, the Landsat 8 project scientist Jim Irons said it best. He said, "On Monday, I go out there and look at my baby sitting on top of an enormous firecracker and hope everything goes well." Fortunately, everything went well, and Landsat 8 is now orbiting Earth and adding about 650 images to the data archive every day. So there's a lot of data in the archive for you to use. I'm going to give you some examples of how Landsat data are used, but first, let's go over some remote sensing 101 as it pertains to Landsat to get all of us on the same page. Landsat uses space-based passive instruments. Passive in this sense means it's measuring energy that's naturally reflected and emitted from Earth. But we need to keep in mind that there's an atmosphere between Earth's surface and the satellite. So some of the sun's energy will be absorbed by the atmosphere, and some of the Earth's energy, or some of the sun's energy will be scattered by the atmosphere. That scattering can lead to hazy-looking images, especially for the blue bands, which are Landsat's shortest wavelength bands. For these blue bands, even on clear days, nearly half of the signal can be coming from light scattered by atmospheric aerosols. When you download Landsat data, you are getting what we call top-of-atmosphere images. USGS also offers Landsat surface reflectance products, which means atmospheric conditions have been accounted for, what we call atmospherically corrected, and the data is provided in units of radiance or reflectance. As I toggle back and forth between these natural color images, you can see the significant difference that can make, especially when you're using the blue bands. When we describe remotely sensed data, we describe it in terms of spectral, spatial, temporal, and radiometric resolution. First, spectral resolution. This tells us which part of the electromagnetic spectrum we are looking at. Landsat looks at visible and infrared wavelengths. Keep in mind, we look at specific parts of the spectrum because we know that objects on Earth reflect energy a certain way at those wavelengths. For example, green and near-infrared energy is strongly reflected by healthy vegetation, while red and blue energy is absorbed. Knowing these physical properties of vegetation allows us to use measurements of reflected light in those regions to figure out things like vegetation location and health. It's helpful to know how Landsat looks at these different spectral regions. The reflected and emitted energy from Earth that reaches the Landsat telescope is filtered into specific spectral regions and then measured. Here's a simple diagram of that process at the top right. The bottom image here is a schematic of Landsat 8's operational land imager's focal plane. What I want you to notice is the stack of filters that are used to separate light into separate bands from selected parts of the spectrum. We end users get to use the measurements from those specific spectral bands. The Landsat 8 has two instruments, the operational land imager I just mentioned, and the thermal infrared sensor. Here, we're looking at the spectral bands that Landsat 8 measures, these color boxes on top, compared to the spectral bands of its predecessor, Landsat 7. The squiggly lines behind in the background show how much energy typically reaches the ground at these various wavelengths on a hazy summer day. You'll notice the amount of energy, or what we call the atmospheric transmission, is lower where the visible bands are. This is especially true for the blue bands, as we've discussed earlier. You'll also notice that Landsat 8 has a new blue-violet band right here. You can also see that the Landsat bands are carefully placed so they are in the regions where a fair amount of energy gets through the atmosphere, the so-called atmospheric windows. But Landsat 8's new band 9 is conspicuously not in one of those windows. Let's take a look at why that is. Here's a natural color of a mountain region in Washington state, and it looks pretty clear. But when we look at that same place using band 9, these wispy, high-altitude clouds appear. Landsat 8's band 9, which is called a cirrus detection band, was actually designed to show where these hard-to-detect clouds are scattering light. Scientists added the band specifically to look for atmospheric scatter, because knowing where these clouds are can help them calculate surface reflectance more accurately. Here's a list of the Landsat 8 bands in a table. What I want you to notice here are the uses. These are some of the surface features that reflect in expected ways in these spectral bands, and therefore can be detected using Landsat bands. Often by using bands in combinations, scales or indices of a specific trait like vegetation greenness or burn severity can be calculated. So when you hear terms like vegetation index or normalized burn ratio, know that these are methods to use spectral information from multiple bands to identify something on the ground. When you open a Landsat scene, there will be one image for each spectral band. Creating color composites help us visually analyze these images. Because we can only see visible light to quote-unquote see information from other bands, we need to put those bands into familiar red, green, blue color channels we can see. Here's an example of creating an RGB image using Landsat 8's second shortwave infrared band, or SWARE-2, its near-infrared band, and its green band, to get a color composite that shows us features we would not otherwise be able to see with our eyes. This is a Landsat 8 image of Carlton, Washington from late July. In this scene, a huge fire known as the Carlton Complex is still burning. But in this natural color composite, you'd be hard-pressed to figure out where it is. In this false color infrared combination, you can see a large brown spot at the bottom center of the image. In this SWARE-1 near-infrared red composite, the fire scar starts to jump out at you in magenta. But here, in the SWARE-2 near-infrared green image, the scar is unmistakably red. So what's going on here? Recently burned areas and bare ground reflect strongly in the shortwave infrared, while lack of living vegetation in the fire-ravaged areas mean that both the near-infrared and green reflection is extremely low. This makes for a very red fire scar when using this band combination. Here are some common RGB composites. The first is a natural color or true color image. This is a close approximate of what you'd see with your eyes if you were to peer through Landsat's telescope. The second is a false color infrared image. And the last, a pseudo-natural color image that uses the near-infrared band and the green channel. And that really makes the green vegetation pop. And avoiding using band 1 in that combination means that you avoid some of the atmospheric scatter that you're seeing in the natural color image. This is the band combination USGS uses for its browse images, and it refers to this combination as, quote, natural color. You'll notice that the spectral band numbers used for the composites are given below each image. USGS provides a handy table to help you keep track of the band numbers used to specify the spectral regions for each satellite at the URL given here. On to spatial resolution. In remote sensing, the spatial resolution can be thought of how much area a single pixel covers. For most of Landsat's bands, the spatial resolution is 30 meters, which we like to say is about the size of a baseball diamond. On the left, we show a yellow 30-meter box superimposed over the baseball diamond at Target Field in Minneapolis, Minnesota. The middle image shows the 15-meter panchromatic or sharpening band. You can see that this pixel extends from about home plate to the pitcher's mound. The right image shows the coarser 100-meter resolution of the thermal infrared bands. This encompasses the entire infield and outfield. Radiometric resolution describes a sensor's ability to discriminate differences in energy. The finer the resolution, the more sensitive it is to detecting small differences in energy. Landsat 8 has a higher radiometric resolution than its predecessors. Basically, what this means is that Landsat 8 produces a clearer image and more precise measurements. This is a Landsat 7 natural color image showing a landscape with lots of bright and dark targets. In this Landsat 8 image of the same area acquired on the same day, you'll notice more detail in the snow on Mount Davis and the wetlands surrounding the lake. And the image looks clearer overall. Okay, next slide here is going to be an animation. This animation is going to help us understand temporal resolution. The Landsat 8 satellite orbits Earth in something called a near-polar orbit. It has a swath 185 kilometers wide and collects data mainly on the sunlit portion of the orbit when it's descending. It orbits at an altitude of 705 kilometers, traveling at approximately 4.7 miles per second. One orbit takes about 99 minutes, and there are approximately 15 orbits in a 24-hour period. The important thing for you to take away from all of this is that the satellite flies over the same location every 16 days. So data can be collected for any given scene every 16 days, what we call our temporal resolution. To organize Landsat data, each of its orbit paths is numbered, and each path is subdivided by rows to give each location on Earth's land surface a unique path row identifier. Each image or scene is about 185 kilometers square. The data that you download from USGS is both radiometrically and geometrically corrected. Radiometric correction makes sure that the Landsat sensors are measuring things the same way over time. Any differences are accounted for in this step. Geometric corrections means any distortions are corrected and the data is converted to real-world coordinates, so you're looking at the right place. So now, onto some uses. I like to show operational uses of Landsat, how data is being used operationally day to day to our benefit. USGS has written that, quote, state water managers in the West use Landsat's thermal sensor to measure water use more accurately and cost effectively than with traditional methods, unquote. Here, we're looking at an image of artificial fields near California's Salton Sea in natural color on the far right and in the thermal band on the left. In the thermal band, the darker fields are cooler, and this means they're using more water. How do we know this? The cooler fields we know this because of something called evapotranspiration. Plants cool down when they transpire, kind of like us perspiring. So the combination of water transpiring from the plants and evaporating from the ground together is known as evapotranspiration, or ET. Knowing this relationship, scientists can use the Landsat's thermal measurements to calculate how much water agricultural fields are using. In other words, by knowing this physical property of plants and soils, thermal information collected by Landsat can be used to estimate water. Here's an example of the Wyoming State Engineer's Office calculating ET using Landsat's thermal band in a program known as Metric. The next example we're going to look at is Landsat's operational uses revolving around wildfires. 3 U.S. wildfire programs regularly use Landsat to perform their duties. 2 of those were born from the aftermath of the 2000 Cerro Grande fire near Bandelier National Monument. Here on the left, we're looking at a natural color Landsat image of the location of the fire about a month before it began. To the upper right, you can see some of the historical cultural monuments in Bandelier. On May 4th, 2000, a routine prescribed burn at the National Monument burned out of control. An unexpected windstorm along with a bad fire hazard rating for the grounds in the area were found to be part of the problem. Additionally, the area is a patchwork of federal lands, as you can see from this map at the lower right. The different colors show different boundaries of various federal responsibility. So once the fire started to spread, it was difficult to know who needed to allocate what resources to fight it. So this was bad. A prescribed fire at a national park caused the town of Los Alamos to be evacuated and threatened a national laboratory with nuclear materials on site. On the left here, we see a natural color Landsat image of 5 days after the fire began, and on the right is a ground-based image. Here, we're looking at the same image, but with the SWIR-2 near-infrared green band combination we discussed earlier. You can see the large burn scar easily here. This image from August of that year shows the large extent of the fire. In the end, 43,000 acres burned, homes were lost, and there was $1 billion in damages. After the investigation, the Land Fire Program was born. The responsibility of this program is to create fuel load maps across all federal lands in order to protect against outdated fire hazard ratings. Land Fire uses Landsat to map vegetation types and fuel loads, and that, together with weather information, can lead to better fire behavior predictions. The other program that was created, the Monitoring Trends and Burn Severity Program, uses Landsat to map the size and severity of all large wildfires nationwide. The map at the bottom right shows large fires across the U.S. The project mapped 15,000 fires that occurred between 1984 and 2000 using Landsat, and now they're mapping fires prior to that time period and after using Landsat. The program that was already in place prior to the Cerro Grande fire was the Burned Area Emergency Response Program. The BEAR program uses Landsat to map the severity of fires so they can help remediate damage in the areas most prone to landslides and other secondary damages after a fire. Well, that's all for me. Jeannie Allen from our team has more introductory materials that she can make available to you if you're interested. Now on to getting data. Jennifer, back to you.
Okay, thank you, Laura. Our second speaker today is Linda Owen, who is a technical lead and provides user support for Landsat data products at the USGS. Linda?
Thank you, Jennifer. It's a pleasure to speak with you all today. I've been supporting the Landsat project here at the Aero Center in Sioux Falls, South Dakota for the majority of the 14 years that I've been here. Today, I'm going to briefly go over the available Landsat data products and how you can search for and download the data from the USGS archives. Now, as Laura mentioned, Landsat satellites have acquired many scenes over the past 40 plus years, and all of that data is archived at the USGS Aero Center. These data are available to all users worldwide, downloadable at no charge. We'll start our presentation today with some high-level details on the Landsat standard data products and their characteristics. I'll then introduce you to the Landsat Look images, and we'll also provide some details on some science data products that are now available. We'll then take a look at the online searching and ordering sites, and I'll end with a demonstration showing you how to download a Landsat 8 scene from Earth Explorer. Now, Landsat standard level 1 data products from Landsats 4, 5, 7, and 8 provide multispectral data at a resolution of 30 meters. Landsat 7 and 8 data also provide a panchromatic band at 15 meters. These data are spatially and geometrically consistent, and the intercalibration of these data enable the construction of long-term data records. We continually improve the radiometric and geometric corrections of the data that increase the value and the usability. Now, data from the multispectral scanner, or MSS sensors, which were aboard the Landsats 1 through 5, are also available. I just don't talk about them here. And they are also very useful in long-term data studies. These standard level 1 data products are delivered in a tarred, zipped, compressed file. And the newer Landsat 8 data files are quite a bit larger than the previous data because we have the additional bands and the data is improved to 16-bit. I've got the file sizes there listed for Landsat 8 compared to Landsat 7, uncompressed and compressed. All the data is processed to full terrain correction when possible, or level 1T. It's processed to a GeoTIFF format and resampled with cubic convolution. And all data is UTM projected. Now, when we say full terrain correction, that means that radiometric and geometric accuracy are both applied to the data by using ground control points. And the geodetic accuracy of that data depends on the certainty of those ground control points and the elevation data that's used. When scenes cannot process to full terrain correction, they fall back to systematic terrain, level 1 GT, or systematic correction, level 1G. The processing level for each scene is noted in the metadata file that is included with the level 1 data product. This slide compares the spectral bands of Landsat 8 to those of Landsat 7. If you're not familiar with the Landsat 8 satellite, it has two sensors on board that collect data. The Operational Land Imager, OLI, sensor contains bands 1 through 9, and the Thermal Infrared sensor, known as TIRS, collects thermal band in bands 10 and 11. When we're looking at the Landsat 8 bands, you'll notice that there are two new spectral bands included. The first is band 1, the coastal aerosol band. This helps in studies in the detection of chlorophyll and suspended materials in the water. And this band is to be used as one band input in a 3-band RGB composite. And as Laura explained earlier, the new Cirrus band, band 9, improves the overall image quality because of better cloud screening. This band is used alone, like Laura demonstrated, so high-level clouds can be detected and compared to the RGB image that may not show those cloudy areas. And band 10 and 11 are the thermal bands collected by the TIR sensor. For most of the Landsat 8 scenes in the archive, the data from both sensors are packaged together to create the Level 1 data product. And the URL listed at the bottom of this page displays these band designations along with those of all Landsat sensors. The Landsat 8 quality band is a created file that contains values that represent bit-packed combinations for surface, atmospheric, and sensor conditions that can affect the overall usefulness of a given pixel within a scene. Used effectively, these bits improve the integrity of the science investigations because it indicates which pixels may be affected by instrument artifacts or subject to cloud contamination. We have a website listed here on the bottom of this slide that provides much more information about the QA band if you are interested in learning more about that. Landsat Look images are products that are also available to download, and they are full spatial resolution browse images derived from that Level 1 data product. They are available for all Landsat data, and they satisfy a broader use without the need for sophisticated processing or software packages. They're easy to download. We have a number of items available. The Landsat Look natural color image is a composite using 3 bands to show a natural looking image. Like Laura explained, it's the pseudo natural color. And the bands used for each of the sensors are listed below that. We also have a thermal image, which is a 1-band grayscale image to quickly show the thermal properties of that scene. And for Landsat 8, we use band 10, and for Landsat 7, we use band 6, high gain. There's also a file that you can download called Landsat Look Images with Geographic Reference. It's a bundle that includes both of those previously mentioned files, including geographic reference files that will allow you to import the data into geographic information systems or into image processing software packages. Also, Landsat 8 includes a quality band Landsat Look in a PNG format. And as I explained about the quality band that you can download with the Level 1 product, this is just a quick look that contains those values that can affect the overall usefulness of the pixels within the scene. We have a website available that describes the Landsat Look images a little more in detail if you're interested in that. Now, all of these can also be easily viewed using the Landsat Look viewer. The Landsat Look viewer was created to allow rapid online viewing and access to the Landsat Look images and the Level 1 data products. It enables interactive exploration at full resolution. You can export graphics. You can export what you're seeing on the screen, called screen scrapes. And there's also a web-based ArcGIS image service available from the Landsat Look viewer help information. Now, we'll talk about Landsat science data products now. We currently have some climate data records and essential climate variables that are either available or being worked on. Now, what these do, they provide an authoritative basis for regional to continental scale identification for historic change, monitoring current conditions, and helping to predict future scenarios. We currently offer the surface reflectance climate data records, which is shown in yellow here. The others listed are planned and will become available in the future. And more information about CDRs and ECVs are available on the website shown below. Now, Landsat surface climate data records use the Level 1 data products as input. And currently, we have them available for all Landsat 7 and most Landsat 4-5 TM data products. They are generated from the LEAD apps processing system, And all data products are available to download for 14 days after they're processed. The file sizes vary based on the products that are selected. One thing to keep in mind, all Landsat surface reflectance climate data records are considered provisional. And we also have prototype Landsat 8 surface reflectance climate data records in the works, and we expect those to be available before the end of calendar year 2014. They will not be generated by LeadEps, but instead will have a new algorithm. And more details regarding that algorithm will be provided on the Landsat website listed here, as well as on the Landsat homepage. All right, I'll just quickly speak to this slide. Listed here are the available spectral indices, which are created using the surface reflectance climate data records. They include a variety of vegetation indices and burn ratio products. And the PDF file listed at the bottom of this slide provides much more information about each of these and how to access those. All right, we'll now talk about how you can get the data. To search and download for Level 1 data products, these portals can be used. The USGS Earth Explorer, which is a primary searching portal for the USGS archives. GloVis is also available, and that is a browse-based viewer for Landsat and a number of other data sets. And as I mentioned earlier, the Landsat Look viewer is available also, and it provides viewing and access to all of the Landsat data products. And also the NASA Reverb interface can also be used to search and download the Landsat data. The Landsat Science data products can be requested from the ESPA on-demand interface, which allows customization such as subsetting, reprojection, and then selecting a specific file format. The surface reflectance data product can also be requested from Earth Explorer. This slide provides contact information for you to reach us with any questions you may have regarding the Landsat missions, the data products, or data access. You can also subscribe to the Landsat updates and the RSS feeds, which will allow you to receive up-to-date information about Landsat. And the main Landsat webpage is also listed here for your convenience. Now, I don't have this added to the slide, but you can also follow us on Twitter at USGS Landsat. Okay, we'll now do a demo on downloading Landsat data from Earth Explorer. Okay, this is the Earth Explorer interface. The first thing you want to do when you access this site is to log in with your USGS login credentials. If you do not have these, you will need to register first. There is no charge to register. We only ask for this information for demographic and reporting purposes. So after registering, you will receive an email to confirm your registration, and then you can log in. Now, while you can conduct searches on Earth Explorer without being logged in, it is required for you to download or submit orders for data products. The first tab is Search Criteria. Here you can enter an address or place name, a particular path row, or land feature. You can also enter latitude, longitude coordinates, select a predefined area, or upload a shape or KML file. You can also click on the map to define your area of interest. For our search today, we'll select Yellowstone Lake in Yellowstone National Park. We'll zoom the map to northwest Wyoming, and we'll create a polygon around the lake. And as you're creating polygons, you can adjust them as you need to. After you select your area of interest, You'll then want to select the date range, which is at the lower left part of this tab. For our search today, we'll select April 1st, 2013 to April 30th, 2013. We'll then go to the Dataset tab. The Landsat Level 1 data are listed under the Landsat Archive category. The land surface temperature data are listed under the Landsat CDR category. Today we'll select L8 OLE tiers for Landsat 8. And after we select the data set, we want to go to additional criteria. Now the additional criteria tab allows you to refine your search. You can enter specific path row range, set your cloud cover limits, or select either day or night scenes or both. For our search today, we will not select any additional criteria. We'll then take a look at the results. The results will be returned in the order of most recently acquired. Now there are many functions on this page on Earth Explorer, but for our demo today, I'm only going to mention a few. However, everything we go over here, as well as all functions, are detailed in the help documentation, which is located at the top right side of the page. Now back to the results, there are icons shown near each result that is returned. The first one, the footprint icon, displays the coverage of the scenes on the map. This allows you to easily see where your area of interest is within the scenes. Now if you see a shopping basket icon near a scene, that means that the Level 1 product is not immediately downloadable, and you need to place an order to have the data processed. When you click on the icon, the item basket text appears on the top menu. You simply click the item basket and follow the steps through to submit the order at no charge. And when processing is complete, and that takes 1 to 3 days, you will be notified by email that the data is ready to download. That Level 1 product then becomes downloadable from this interface as well. The other icon I will talk about today is the green arrow. When clicked, this displays the data products available to download. The Landsat Look images are displayed, as well as the Level 1 product. When you click the download button, the file will be saved to your system. Remember, the files are delivered in tarred zip compressed file package. You will need to use file extraction tools to pull the tarball from the zipped file, and then you need to open the tar file. And when you do that, you will see all of the bands that are contained within the Level 1 product. You can save the files to your system and then load them into the image processing software. Well, I hope this quick demo was useful to you today. As I mentioned earlier, there are additional options and many functions of Earth Explorer that we didn't go over, but they can all be found in the help documentation. And of course, Landsat user services are here available to help you, so please do not hesitate to contact us. Okay, thank you, Jennifer.
Okay, thanks, Linda. Finally, our third speaker today is Jeannie Allen, who is an Education and Public Engagement Specialist at NASA Goddard Space Flight Center. Jeannie?
Hello, everyone. Can you hear me all right? If you can't, let Jennifer know. I have also been with Landsat as a contractor to NASA for about 13 years. And basically, my job is to be a bridge between the science community and the rest of the world. So I would be very happy to hear from you if at any point you are looking for learning and teaching resources that you can't find. So what I'm going to do today is cover some of the education resources that are available to you on the event website. There, I would like to suggest that you stick with me as I go through this handful of ones that I want you to be particularly aware of, and then you can download the complete file and do your own searches later on. The whole file is organized in terms of background and remote sensing, Landsat-specific sites, some learning activities, where to get the data, images and movies, software and tutorials, and then a handful of resources that are available on request to me directly. In terms of general background for remote sensing and also in terms of keeping up with what is happening, the Earth Observatory is an excellent place to go. It has image of the day, it has feature stories about how people are using remote sensing, about how the work is done. It has data, maps, and more. Another really fabulous resource that I always use with when I'm giving workshops is the Tour of the Electromagnetic Spectrum, which is a video series looking at different wavelength ranges and how they're used. It also has a 5-minute trailer that is extremely helpful in terms of making this invisible energy more tangible for people. So go take a look at that one. There's a couple of background articles on how to really understand, interpret, study a satellite image if you are new to it. This is one on Earth Observatory, How to Interpret a Satellite Image, 5 Tips and Strategies. It's really a way of heightening your brain's awareness of what you might automatically do, but that's great. And a second article, somewhat similar to it, is how to basically get a basic understanding dealing with color in satellite imagery. Why is that forest red and that cloud blue? Since, as Laura explained, Landsat 5, 7, and 8 has been joint USGS NASA website missions, there are Landsat-specific websites at each of those agencies. There are 2 Landsat at NASA websites. I recommend you look at them both. They're full of resources for understanding the data and what happens to them. This is the education page for Landsat at NASA. So we have it divided into sections for students, for classroom educators, and for informal educators. Landsat at USGS is highly informative. I'm particularly like the frequently asked questions pages that they have, because there's some differences between 7 and 8, as you know, that you can use a little bit of help in understanding. Then there's a set of learning and teaching resources funded by the National Science Foundation, specifically for people who already use GIS. And we actually have a participant on, Doug Wendell, who's been a participant in that project. So go there if you are interested in that aspect of things, and just be aware that that URL is going to change. So you will have my contact information at the end of the webinar. Get in touch if you're interested in them. So there are not only exercises created by the participating instructors of GIS, there's also what we're calling concept modules that are YouTube videos that deal with fundamental aspects of remote sensing analysis. And they're also the agendas that we used for these professional development workshops and all of the resources that we use for them. So you can give your own workshops. NASA Wavelengths is a one-stop shop primarily for kindergarten through 12th grade. Thought I'd recommend you take a look at it if you're looking for learning resources. It's pretty easy to find wonderful stuff there. There's an instrument that I found particularly useful for teaching. It's handheld, and you can't use it to really compare what you're seeing on the ground with what the satellite is recording, but it helps to make a connection between what people experience on the ground and what the instruments on the orbiting satellites are doing. You can see in this picture there's different colors representing different wavelength ranges. And you hold that spectrometer onto the surface, you put it on the surface that you want to measure, and then you press down on each of those little colors, and you'll get a number a little arrow will come up and tell you how much light is being reflected in that particular wavelength range. That's a pretty cool tool. Software and tutorials. There's Earth Observatory has an article, Quick Guide to Earth Explorer for Landsat 8. There are 2 USGS tutorials here on this page. And in addition, there's a longer, more extensive tutorial by the Canada Centre for Remote Sensing, which we have used in working with those GIS instructors. It's a wonderful level. It's a bit more than high school, but terrific. Then 3 other sets of resources that you can have if you get in touch with me directly. I'm disseminating that way because they're still being tweaked in a minor way for publication. There's a Landsat Train the Educator kit, which is all the resources you need to give your own workshops. There's the second one is How Landsat Works. It's a very introductory level PowerPoint about how the scenes are made, all the data layers, how you can combine them in different ways. And then I have more tutorials. There are 3 tutorials, one on how to download and open Landsat scenes from Glovis, one on how to open them in different band combinations with ImageJ, which is no-charge software from the National Institutes of Health, and then one tutorial on how to open them in different band combinations using Photoshop. So again, take a look at the longer list of annotated resources and get in touch with me if you have any questions about them. And our last slide here is contact information for all of us speakers and for Jennifer. So thank you, everyone. It's been very enjoyable to be with you today. Back to you, Jennifer.
Okay, thank you, Jeannie. So what we're going to do now is move to our final set of polling questions, and we will give these just a couple of minutes or so. And then after that, we'll move directly to the question and answer portion of the webinar. So make sure you stay in the room and or stay on the line to participate in the questions and answer period. Thank you. So we'll give this just a couple minutes here. Thanks. So just a couple of points while people are addressing the polling questions. The slides will be available for download once we jump to the question and answer period, which is going to follow in about a minute or so. There's a file sharing pod, so I'll leave the room open after we're finished, and feel free to download the slides. That feature is actually persistent within Adobe Connect, so after this webinar has been posted online to both our NASA Earth Data YouTube channel as well as to my online catalog, and the URLs provided on the last slide, you'll still be able to download the slides. And certainly if there are any issues at all, please feel free to email me and I will make sure that you have access to the content. And then, let's see, another thing I wanted to point out, if you had a question that you had written within the polling questions, the speakers will be able to, if you don't ask it within the Q&A period, to follow in a minute, the speakers will be able to also follow up with you offline. So not to worry, this content has been captured. If you asked a question much earlier, it's still contained within the final log. Okay? We'll give it just a few more seconds and then we'll move to the Q&A. Thank you. Okay, everybody, we're going to go ahead and move along to the Q&A period at this point. Here. As you can see, I have the presentations here. I've got the complete list of educator resources as well as the introductory level presentation that Jeannie Allen mentioned within this file as well. And that is the How Landsat Works in PDF format. Okay, it's quite a large file, but again, if anyone has questions, contact me separately. So the first question today, just scroll down a bit, so please bear with me. Okay, the first question today is, what is the difference between Thermal 1, Band 10, and Thermal 2, Band 11? Anybody on the speaker panel, just please feel free to answer.
That would be Linda or Laura.
Yep.
It takes time to unmute yourself.
Yeah, it does. This is Linda here. Basically, it's just two thermal channels that are available. If we look back at those band combinations in our slides, they are both used for the thermal studies, the water studies that Laura spoke about.
And when you look at, you want to look at that, the graph, it just kind of shows where on the electromagnetic spectrum they are. They're one's, in the higher wavelength than the other, but they're close together. But you can see that if you want to see it visually.
Okay, thank you, Laura, and also thank you, Linda. The second question is, what is the spatial resolution of a digital elevation model to create level 1T products? Is it the same as the best available resolution from USGS, which varies from place to place? This is really kind of there are several questions embedded, so I'll add the final comment. If we need to eliminate hillshade effect using our own digital elevation model at finer resolution, which is the best Landsat product to start with? And either Laura or Linda.
Okay, I'll jump in and take this one. Well, the elevation sources do vary. The elevation sources that go into the level 1 processing do vary. And we realize some of those may not be optimal for all areas of the world. I don't have a lot of details in front of me right now about exactly what would be best. All I can say is investigations are underway for other elevation sources. And we ask if you'd like to email us in with that. We can certainly get you some more detailed information back about those.
And Li-Heng, I could also have Linda follow up with your email address. Again, that is captured in the question and answer log, so she can possibly follow up offline. Okay, next.
Certainly.
Next question is, how long is the available CDR data? Is this available for all of, okay. So it seems as though this might be a two-part regarding both the temporal and the spatial coverage. Javier, is that correct? Because is this available for all of the world? So are you asking both about the temporal availability and also the spatial availability, I'm guessing.
Okay. And Jennifer, that was CDR data?
Yes, that's correct.
Okay. The Landsat climate data records are available for all scenes worldwide right now for Landsat 7 and most of Landsat 4.5 TM scenes. So it is available worldwide. And as it uses the level 1 input, it will be the 30-meter spectral resolution.
Okay, great. Thank you, Linda. The next question is, are the images for rural areas also full terrain corrected?
Well, as I mentioned in my presentation, the processing level, it can vary. We do process everything to the highest level possible, the level 1T. Depending on the ground control points are what really drive that correction. Now, we could have areas of the world, especially clouds, snow, ice, water, that can set those ground control points off that will not allow the product to be processed to the full L1T. Over land, however, if it's a clear day, if the data from the satellite downlink is high quality and we have all the ancillary files to process to the level 1T, that is what is created.
Okay, fantastic. Thank you, Linda. The next question is, I noticed Landsat CDR is unavailable for Landsat 8 on Earth Explorer. What is the best way to batch order Landsat 8 surface reflectance products?
Well, Landsat 8 will be available by the end of this year, by the end of 2014. And through the ESPA interface, right now we do have RSS feeds and a bulk mechanism that's detailed through the ESPA help web page, I guess. It's all linked from the ESPA on-demand interface. But like I said, Landsat 8, we are expecting that to be available by the end of this year.
Okay, great. Next question is, are the ATBD files available for the product?
I will have to check on that. The metadata contains much information about each scene, but those particular files, that particular data, that'd be probably best to contact us and we can get some information back to you.
Okay, great. The next question is from Erin. I am interested in surface temperature data. I have used Landsat Look Viewer, but I am not sure how to determine the actual digital values from the image. What is the best way to do that?
Well, Erin, if you're looking for land surface temperature, I will say that is also an upcoming product from the ESPA interface. But using the Landsat Look Viewer, you definitely want to download the full level 1 data from there. Just looking at the interface and using the screen image and the views would not provide you the information.
And the other thing I would add is that perhaps in the interim, we do have a MODIS land surface temperature data product that is available from our Land Processes Distributed Active Archive Center, which is also out in Sioux Falls, South Dakota, and is a NASA-funded USGS data center, although not, at the same resolution, but perhaps something to take a look at. Wouldn't you agree, Linda, that that would be something to take a look at in the meanwhile?
Yes, thank you.
All right, perfect. So the next question, Erin, I can email you on that note, actually. Jack, hi Jack. How do you handle matching adjoining image edges for Landsat Look images?
Well, the Landsat Look Viewer, especially if you're wanting to do those screen scrapes, sometimes it can be challenging just because you are looking at different scenes from different days, the paths. When it comes to that, what I generally do instead of doing the screen export is download the Landsat Look image for each of those, and I manually put them together in Photoshop. Now, to say you can also export that display image for both um, for both scenes and then take them each into Photoshop as well. But yeah, that is a challenge right now in the Landsat Look Viewer. If you can see the seams and the different lines of the paths of the images.
Thank you, Linda. So the next question is from Nanette. Is only Landsat 7 geo and radiometrically corrected?
Actually, no. As I mentioned, we strive to provide all the data products on Landsats 1 through 8, all full terrain corrected. I guess they all are when possible. When we have all the ancillary files and all the ground control points line up, we can create those products.
Okay, thanks, Linda. Next question is, why use cubic convolution as a resampling method? Does this impair the integrity of pixel values and or make user co-registration more difficult?
Oh, let's see. I've got some information on that. Well, cubic convolution was selected. I don't have the notes in front of me here. Boy, you know, I can certainly get some information to you about that.
But it was a carefully made decision that the Landsat science team
Right.
thought about for a long time, and they decided they were going to go with one format to make all the data free and processing available to everyone, that this was the smartest way to go.
Okay, so thanks, Linda and Laura. It sounds like, Scott, that someone will get back in touch with you with some more details on this question, okay? The next
Definitely.
question is, what product is best for vegetation classification?
Well, the level 1 product would be best. And looking at the bands that both Laura, in Laura's demonstrations of the images, your vegetation bands, your SWIR and your near infrareds are probably the best band combinations to use for that. Laura, do you have anything to add?
Well, product-wise, some of those indices that are going to come up, if you want to use the NDVI indice, that can help you if you're trying to just figure out where vegetation is healthy. But if you're trying to figure out the different types of vegetation, then yeah, using the level 1 product and doing, the level 1 data is probably the best way to go.
All right, thank you. The next question also has a comment as well from Jesus. I want to thank you about the quality assessment band. However, I'm still having problems using the 16-bit data, so I'm using decimal pixel values directly provided in level 1T. So are you thinking about providing Landsat users with an online tool?
Okay, if you're speaking about a tool to unpack those bits, there is a tool available through from the Landsat website, from the Landsat 8 Quality Assessment Band webpage. There are tools available for you to unpack those bits and use them.
Okay, thanks, Linda. Next question is, how much time does it take for a request for more than one image, for instance, 10?
If you're placing a processing order online through Earth Explorer or GLOVIS or the Landsat Look Viewer, generally the data is processed within a day or two. Depending on the queue in our processing, it could be longer, but they have been really good about getting the data out in a timely manner. Now, if you're talking about the surface reflectance data products, that's based on the number of orders in the queue and how busy the processing systems are, but they are processed generally within the 1 to 3 day time period.
Okay, great. Thank you, Linda. The next question is, can you please shed some more light on the usefulness of the Landsat climate data?
Well, the Landsat climate data records, the surface reflectance data product is a higher level atmospherically corrected data product that is becoming very useful in science studies.
And I think one of the reasons that it's really nice is that the science team has provided these algorithms that you are getting surface reflectance, so it's easier from looking at different time periods to look at the surface reflectance because you don't have to worry about different atmospheric conditions on different days. So that's one of the great resources about these data products.
Okay, so we'll take a few more questions here, and if we don't get to, until 3:15, if we don't get to all of them, those questions will be answered separately by way of email because I want to allow enough time for people to download the files at the end here. And actually, if you highlight a file, you're able to download that file, just to let you guys know. The next question is, can ALTA-2 be used Can ALTA-2 be used for ground truthing purposes, such as ground truthing of land cover extracted from Landsat images?
Hi, this is Jeannie. I would say no. It's a teaching tool, but it's not accurate enough to be used for any kind of scientific purpose.
Okay, thank you. The next question, does Landsat see through clouds?
Landsat doesn't see through clouds in the manner that we think of radar seeing through clouds. However, when you use the longer wavelength, the shortwave infrared, you are able to not get as much scattering from the clouds. So when we were looking at the natural color versus that pseudo-natural color, you see a lot less contamination from the clouds using those longer band lengths. And then actually in the thermal, a cloud's actually going to show up as cooler. That's all.
Okay, thank you, Laura. And also, Matthew, if at some point in time you're interested in radar or synthetic aperture radar data, we do have data at the NASA-funded Alaska Satellite Facility, DAC, which is in Fairbanks, Alaska. And that is asf.alaska.edu, I believe. I can follow up if you like separately as well. Next question, do you have plans to publish more data via web services for programmatic access to particular regions of interest?
I would say yes. We're always working to make the data easier to access. Currently, I do not know of a timeline or anything like that, but I would just be in touch with us, and we can certainly give you information when that does become available.
Okay, thanks, Linda. The next question is, does PS maintain geo information when matching edges? Does Photoshop maintain geo information when matching edges? I think this is kind of in the same vein, I believe. I can't remember if it was Laura or Linda who addressed this in an earlier question.
Yeah. Photoshop, I have done that and done that in Photoshop. It's a manual process, especially when you are dealing with scenes from different days, different sun angles, that sort of thing, clouds, those sort of factors all factor in when mosaicing or tiling scenes together.
Okay, thanks, Linda. If you seam together two Landsat images, will all the spectral values be the same? Excuse me, will the spectral values be the same?
Yes, if the data you input, if you put them together, the spectral data will be retained from each of those images. They do need to be the same, like in Envy or Photoshop or other image software. Most of them, if you try to put together two files or scenes that are spectrally different, they will alert you to that. But yeah, I know Photoshop or in Envy and ERDAS, when you do put them together, they do retain the spectral information.
Okay, the next question is, what are the advantages to work with TOA and CDR products?
That's similar to what we talked about before. The TOA is the top of atmosphere, whereas the CDR products, they're often surface reflectance, so they've been atmospherically corrected, so they're taking out the differences in atmospheric conditions that happen when you're trying to compare scenes.
Okay, great. The next question is, do you know the moment when the users will find Landsat 8 dates with model LEDAPS corrections? I'm not sure if I'm saying that acronym really.
Okay. Jennifer, can you repeat that question?
Sure. Do you know the moment when, I guess it's, do you know when users will be able to find Landsat 8 dates with model LEDAPS corrections?
Okay. Well, like I mentioned in my presentation and another question earlier, the Landsat 8 surface reflectance data product will be available by the end of this year. However, there are new algorithms to take advantage of the unique characteristics of the Landsat 8 data. New algorithms are being worked on. We'll have all of that documented online and can certainly provide information to whoever's interested in that when it does become available.
Okay, thanks, Linda. We've got time for just a few more questions. Is there any available standard tool for Landsat image calibration?
Laura, are you aware?
Well, I guess it depends on what you mean by calibration. I don't know of any standard tools, but as far as if you're trying to get to a product such as surface reflectance, the best answer is just using the climate data records that USGS provides for you, because they've dealt with that type of atmospheric correction. But as far as image calibration, we have a team of scientists both at USGS and at NASA that work together to make sure that calibration did information. I'm not exactly sure how to answer that, but I think that's a general direction of what there is.
Okay, thanks a lot, Laura. The next question is there any published method for Landsat 8 land surface temperature retrieval?
Not yet.
Yeah.
Laura, did you have anything to add to that?
No, I think there are a number of teams working on it, so I hope there's something published soon.
Yep.
Okay. Well, thank you. The next question, and it looks like this could be the last question, unless someone has something else. What is the best way to do a geometric correction for rural areas like rangelands in Peru?
Well, and I'm assuming that this data then is not received full terrain correction or systematic terrain corrected data. The systematic correction, if they need to manually register that data if it is off with other data they have that they know is completely corrected for the terrain. So it is a manual process if they are working with some data that's not completely terrain corrected.
Okay, does that answer your question if you're still on the line? I don't see a first name otherwise. I know this individual entered as a guest because registration was full. Okay, great. Thank you so much. I don't see any further questions here. Does anybody else have any questions? I would like to take this opportunity to thank you so very much for not only participating, but for sharing such valuable feedback regarding the Landsat data products as well as Landsat data access and future topics. It's really important information, and that will help us in the future as we identify upcoming webinars in the months to come. Let's see if we've got any. It's great to see, quote unquote, many of you that I have had participate in the past, so thank you again. What I'll do at this point is, if there are no further questions, we will log off from the telecon itself. However, I will leave the room open for you until 3:30 p.m. our time, at which point my seminar time will be logged off. And of course, if you have any questions, feel free to send me an email if you'd like the contact information again for any of our speakers or user services contact for USGS. Just let me know. And
Jennifer, it's Jeannie. I have a question here. Under the files, which are posted for people to download, right now all I'm seeing is upload file. Maybe that's because I'm a presenter.
If you click on the file, highlight the file, it allows you to download.
Oh, there it goes. Okay. Got it. Thank you.
Sure. So thanks so much, everybody. If there are no further questions, and I don't see any, we will go ahead and you're welcome. Thank you. Thanks to all of you. It's what makes these successful, so thanks so much. We're going to go ahead and log off from the telecon, but the room will still be open. If you have a question, go ahead and type it in, and perhaps we'll see you at an upcoming webinar. All right, thanks, everybody. We're logging off the telecon
Thanks, Jennifer.
now. Thank you. Thanks, ladies.
Thanks.
All right.